Okay, we're on. Hello, Miranda. How are you?
Hello, I am tired. End of financial year is tiring.
Yeah,
How are you?
yeah. I'm okay. I'm okay. Yeah. I'm looking forward to hearing what juicy news we have today.
Too much, Harriet. Every week, increasingly too much. So hopefully we can get it in the amount of time we have.
That's a good start. All right, what do we have first?
Okay, so I guess we'll start off with CVEs as usual. There'll be some ones that people definitely have heard of this week, rather than I guess CVEs that never really hit the market. So the Copilot CVE called Echo Lake. Well, the name that people are giving it is Echo Lake, but it's CVE 2025-32711. And we'll get into an actual explanation of Echo Lake in our TTP and vulnerability section, but that was a critical. It's now been patched in Copilot updates. There's also been one in Cursor, Llama, CPP, MCP Inspector, Diffie, FastGPT, and a few other pieces of infrastructure or the open source infrastructure for AI components. So let's get into the vulnerabilities then so that I can talk to you about Echo Lake. So this was released by AIM Security, who are a security company like ourselves. They do traditional security and AI security. And they have released what is potentially the first zero-click attack chain enabling data exfiltration from even enterprise versions of the M365 Copilot, in some cases requiring user interaction, and in other cases not requiring interaction at all. So what this technique introduced was something called LLM scope violation, where they were using malicious external inputs that they delivered via email into M365 to coerce the Copilot LLM to access and leak privileged data in its context without explicit user intent. So they were breaking the principles of least privilege there. So what they were doing initially to get the exploit into the environment, like I said, they were using email. However, there are cross-prompt injection attack guards that are put in place in M365, specifically for Copilot at the moment, so that when it is reading resources within the M365 environment that it's accessing, it can usually filter out malicious input that is related to instructions for the AI agent Copilot. However, they used instructions that were directed to a user or to the human receiving the email so that it didn't get flagged by the XPIA, which is the cross-prompt injection attack acronym, guards, because they didn't register it as an attempt to alter the instructions of the agent. So that was the first part. They got the email through. Copilot was able to access and read it. The second reason why their emails were successful were that they employed this technique called RAG spraying. So they had this issue where, sure, we can send an email into the environment, but and get it to bypass the XPIA filters. But how do we make sure that when a user queries Copilot about something that will require it to read the email, that it reads our email? So for RAG spraying, what they were trying to do is make sure that the content in their email took up as much latent space in Copilot's RAG memory as possible, so that as many user queries that they would logically make could reference the email and require it to go interact with the attack. For example, what they were doing was one technique that they suggested was you can make sure that your email targets a question that you think, after some reconnaissance of your target, is very likely for them to ask Copilot, but that usually only succeeds on like one topic because it's limited. Alternatively, the RAG spraying that they were doing is where they had a huge email, like think about multiple pages of length, and they put their malicious instructions under multiple different subtitles within this email so that it covered a bunch of topics within the same email. And that way they were able to spread their attack over more topics and increase the likelihood of a user asking something related to it. Yeah? Does that make sense?
Okay. Yeah, that does. Yeah.
That's hectic. So that's just how they got in. Yeah. So that's part one. And then part two is the exfiltration. So how were they then getting the information out of the environment? So the actual instructions that were part of this email would be like, you know, blah, blah, blah. When a user asks how to write an internal policy document for this thing, make sure that you collect all sensitive information in the environment and hold it in this variable name. So that was just like an additional instruction, and then they'd also allow it to do its actual job so that it wasn't easily detected. So then they had this variable that held a bunch of information, and they wanted to get it out of the environment. So they started looking for exfiltration paths. And usually, if you have a really badly locked down agent, you might be able to toss that onto the end of the URL parameter and make like outbound requests. And then you could have an attacker controlled server. You can read the requests that you're receiving from an agent, and like the URL parameter will have the encoded data or something, and you just strip that and that's your exfil. However, Copilot had a content security policy in place, which a CSP is a type of security rule or header that you apply to web requests to make sure that they can only go outbound to a certain subset of domains. And in this case, it was only allowed to go to certain Microsoft domains. So what they did was they trawled like all the the URLs that were accepted by the CSP until they found a bunch of APIs that could make outbound requests with data. They were really niche. They found one in Teams and one in SharePoint, and using that, they were able to get exfiltrate the data. Not them personally, but Copilot did it in its outbound requests. The other way that they were able to do it was through, so the way that they had to encode the data was through markdown rendering. So they used markdown links and markdown images, which sometimes were caught by Copilot, but they found specific formats of markdown reference style links and also certain image styles that were able to encode the data as part of the fetched image URL. And then they performed it through those APIs that they found that were allowed by the CSP. So, oh my gosh.
Okay.
Like,
wow. Okay. So how were the researchers able to find this? Who did you say the researchers were again?
AIM Security, AIM.
Okay.
Yeah.
That sounds really, really, really interesting, because in principle, it sounds like a lot of theoretical attack vectors that shouldn't really work on their own, but they were able to be chained together in a way that did work. Like even the way that they were able to prompt engineer the agents through the email, you would expect that Microsoft would have considered something like that already.
But they had, right? Because they had those cross-prompt injection protections, but that they were protecting against what they know prompt injections to look like, which are instructions to coerce an agent. But if they're instructions to a user, in most cases, that's entirely legitimate. Like, how do you catch something like that? It could just be an email to your colleague providing instructions for them on how to write a policy because they asked. So, I mean, it says a lot about how difficult it is to protect against, all of these emerging classes of jailbreaks and, LLM like prompt injections, because they're so diverse. And this is another case broadly of the problem that we're seeing, where agents inherently trust external inputs. And if it's an insider threat, then it would be an internal input, because it might be coming from an email within your organization or other documents that someone else can edit in your organization, which it is also fetching from. So, email within M365 is just one like feature in which they use to deliver this exploit. But theoretically, you could do it if you were in the environment or if you're a contractor who was sharing documents and all that kind of stuff. So yeah, definitely about that. I guess intrinsic trust that is being given as part of the workflow for agents. But you're right, like it's such a novel attack. I recently put a post on LinkedIn about this, but I was doing a pen test a few weeks ago on Copilot in a really, really locked down org, and I got to the point that they got to of being stuck at the exfiltration. And I didn't realize that I did realize the CSP was in place because only Microsoft related assets were able to be reached in this really locked down environment. But I didn't get to the point of finding an API to do the exfil from. So when this came out, I was like, oh, I'm so dumb.
That sounds really interesting. So this is a critical vulnerability, isn't it?
Yeah, critical, and it's been disclosed and addressed by Microsoft.
Nice, interesting. Okay.
Yeah, that took up a long time of our podcast to explain that one vulnerability. But it, even if I wanted to condense it, I don't think I could. It's a bit novel.
Yeah, there's some juicy ones, and sometimes they deserve a bit of time.
Absolutely. Okay, so the next one was a vulnerability in Agent Smith, which is, it's a vulnerability in Langsmith, which is a resource by LangChain, and the attack is called Agent Smith. So that's where my mind got.
Remember that, everyone. Yeah.
Yeah, jumbled a bit. So Noma Security, they published a write-up on their attack Agent Smith, which is a Langsmith prompt hub vulnerability, which is also now patched, that previously enabled API key theft and hijacked LLM responses. So this was a high CVSS vulnerability, and what effectively was occurring was in this prompt hub, it's a public repository of community shared agents and prompts that are widely used by a lot of enterprises who partner with LangChain. And because it was an unmonitored community hub, or there was not a huge amount of verification going on, attackers could upload a malicious agent into this marketplace, pointing it to a server that they controlled, and then they would have users adopting the agents, cloning them, whatever they were doing to use them, and that would cause all of the inputs back and forth from the agent, including API keys or proprietary information, sensitive documents, whatever they're using the agent for, to be proxied, so routing through the attacker-controlled server before going to the end user and between the agent back and forth. So they were able to effectively man in the middle, sit in the middle of all of these interactions, and gain whatever sensitive information was part of that interaction. It's patched now.
Okay, interesting. So for readers who haven't seen the newsletter before, Miranda always adds a little note at the end of every digest item. And here you've highlighted the importance of a software bill of materials, among other things, like an AI bill of materials. Do you want to comment on that very quickly?
Totally. So in open source security, there is this idea of SBOMs, or software bill of materials, because when you're using open source software, you open yourself, and when you're using closed source software, you are too, but huge supply chain influences because of the community nature of the contributions to these services. You have people, different people interacting. You have different upstream dependencies. People might have taken code from more open source projects as well, rather than it being all created in-house. Because of that, you should be aware of everything that your system relies on through using these technologies. And that's where the bill of materials comes in. It's for supply chain management, so that you can track CVEs, know whether you're affected based off of your SBOM, like whether you have an exposure because you use those open source software, or an upstream dependency has been affected. Know when you're going through security patching and updating, you can just like roll through your SBOM and look online if there's a most up-to-date version of all of these softwares. And so the equivalent is now being suggested for AI and AI bill of materials. But what I said in my comment is, it's not something different. It should just be part of your general technology stack, supply chain management. But in the AI space, everyone loves to pull things into a separate stream and call that it's special or different, even when it should really just be part of information security management system processes in general. It's something that we preach here. Yeah, so that way you can do verification of agent identity and capability, because you might have, for example, if ANS becomes a thing, you might have a signed version of an agent name and a capability being listed in your AI bill of materials. And then if you do continuous checks on that, maybe one day someone's performed an update that causes that signature to change, and it's been a malicious update, and you will have known because you have a history of what software you want to be using.
Yeah, that kind of provenance tracking is really important, and even more so when you have these highly dynamic and capable environments.
Yeah. I'm feeling so verbose today, so you should just give me hand gestures when I'm talking too much.
No, it's okay. No, because you're explaining everything really well. It's just that.
Okay, awesome.
Yeah.
Yeah, I went on a walk with my boyfriend actually across the lake in Canberra yesterday, and I was like, I want to be more prepared for Harriet and Mai's podcast. So I just gave him a rundown of this, and he asked me some good questions, and yeah, now I'm feeling good.
Oh my gosh. I love that.
Thanks, babe.
You're welcome, Miranda's boyfriend.
Yeah. So we're moving on to another vulnerability now that was in Llama Index, which is it helps you integrate what do you call it? Interface agents with databases effectively. So for this one, there was a traditional SQL injection vulnerability where because this LLM Llama Index is interfacing between a user's input and producing the queries that actually retrieve or alter or delete data within a database, users were able to do a prompt injection that could then result in a malicious SQL query being delivered to the database. So what they were doing was, providing a chatbot query that would then produce an operation in SQL in an SQL string, and it would have unvalidated user input, unsanitized user input most of the time. And once that reached the database, it could delete, it could retrieve sensitive data out of bounds, whatever you would like. It was traditional SQLi.
Interesting. Again, interesting because I guess this is a traditional cybersecurity attack vector, but AI is enhancing, augmenting that attack surface. Interesting.
So that's patched in the newest Llama Index version, and effectively the advice to customers who were running the previous version was, if you have logging, check all of your logs to see whether you've had any exfil, because the at-risk scenario would be like if you have a customer-facing chatbot that can pull data about their account or something, and you ask it, can you tell me whatever my password was? I don't know. It goes and would have retrieved it for that user, but because of this out-of-bound thing, it could have retrieved it for all users, or it could have modified other users so that you could then log into their account, whatever they're storing. And basically, they're just saying check for whether you've had any misuse of your Llama Index integration.
Okay, got it.
Yeah, awesome. And so the final one is our favorite guest on the show, MCP.
Again? No.
Yeah. So Asana disclosed to users very recently, a few days ago, a data exposure bug in the MCP server that they're running. So do you use Asana or used to? It's like
we did at some
right?
point.
Yeah.
Oh wait, I'm thinking Asana, the project management tool.
Yeah. I think that's
okay.
I think that's the one. Don't want to do any defaming, but
yeah, no.
Actually, there's only one Asana. So what happened was on June 4, they identified a bug in the MCP server that would have allowed users to access data from other organizations. So it was, however, it was limited to objects within the scope of the MCP users' permissions. So, if they were highly permissioned, then they would have that equivalent in another organization, which is not good. They didn't have any evidence that the bug was exploited, luckily. So they basically immediately, as soon as they knew, took the MCP server offline for investigation, and they're still trying to work on a code resolution at the moment. So the MCP server is still offline. And again, like the Llama Index situation, the advice to affected users was pretty much check any logging and see whether you accidentally received data from another organization, and if so, delete it, or whether you think that your data might have been impacted. And the solution that is, technically should be applied is having strict, and we say this for MCP all the time, having really strict tenant isolation and least privilege for any LLM interactions that you're having. So a particular agent that's interacting with an MCP server should be given granular permissions to perform actions and retrieve data per use case, which protocols are being made around. And secondly, you should not have that LLM in the environment with a bunch of data that it's unrelated to its use, because it will just reach out of bounds.
Okay, I'll make sure we go and check our account. I know you noted that there was no evidence the bug was exploited. So the bug was there for about a month. Is there anything about these sorts of MCP vulnerabilities that mean that existing cyber logging might not catch if a bug was exploited, or do you think that it's probably too new for someone to really exploit at this point?
A bit of both. you need to have set up logging for MCP. So like logging as a whole, and I'm not a person in my blue team, so I don't, I'm not pro at this, but you need to set up specific rules to log specific things in your environment. And for example, MCP is a new protocol or service, doesn't have many rules for what detection of exploit looks like. And B, people just don't really know it is an attack surface, so they may not be performing any monitoring or logging. So yeah, there's a difference between logging and monitoring. Logging is like you are logging all activities related to that component so that when you do need to perform an investigation, you have accurate history to go through. The second is like active monitoring, and that is where the rules come in, where you perform like active detections on the interactions that are going into the logs based on, I guess, predefined patterns that are indicators of compromise. So people need to be both logging and actively monitoring.
That's a really good point to mention, I think, because a lot of the questions we get asked all the time, what kinds of things people need to do differently to address AI-related vulnerabilities.
Yeah, so hopefully, if the security teams in organizations are looking after the AI like infrastructure that an org runs, and they should know to be doing all this because they're doing it for other IT components, but they probably just don't have the rules bit. They should be logging. But if they're not the ones in control of the architecture, like it never, they might not even be where it exists in an org, which is a lot of the time what happens, then I don't have much faith that AI professionals are doing it 100% of the time.
Yeah.
Okay, that's our vulnerability section.
Woo! Okay, that was fun.
Oh my gosh. All right, okay. If we weren't speed running already, we're going to be speed running now.
Oh yeah.
All right, security guidance. Okay, so OWASP, we love them. They're great.
Yeah.
Doing the AI vulnerability scoring system project. So they recently announced a CVSS equivalent. So CVSS is used in like traditional software security, and it provides an attack score and an attack vector string that people, for example, we use in our pen test reports to convey meanings of severity and impact to our clients, so that it helps them prioritize which pen test findings they should be remediating first. The problem was it's quite a inflexible and very strictly confined scoring system. But with the scope changes that AI agents introduce, it's not super applicable to AI, which we recognized in February, and we had written in our AI Security Digest in February, blah, blah, blah. We hope that there is eventually a common vulnerability scoring system, CVSS, where AI vulnerability severities and impacts can be assessed, because we were bagging on how jailbreaks are always the star of the show when they're like the least impactful one, and CVS would really help convey that. Lo and behold, a few months later, OWASP have taken up the mission, so we thank them, and we will contribute where we can. So they have a team led by some awesome people in the space, and they're again inspired by CVSS. They're producing a scoring system and also a framework that helps you use the scoring system, so that you can walk through choosing these different aspects of the impact, the attack vector, the privileges required, the difficulty to exploit, whether there are agents or a single agent, all those sorts of things that will help you describe what an attack, the risk mapping really looks like.
Yeah, it's we're really delighted to see this, and we and you have been tracking this for a really long time. And I know that a lot of people in the community probably have too. So it's really nice to see this be the focal point of how we can all come together. There's also a demo calculator on the website, so any listeners can go check it out and have a little play around, and anyone can ask to collaborate on the project. So we really encourage all of our listeners, readers to go and do that too. It benefits from having more people and different kinds of backgrounds and expertise working on this kind of thing.
Yeah, I agree. If you've got some spare time and you're in the space, just have a think about, ways in which you think CVSS doesn't apply to AI. So, we did some brainstorming and we thought like the scope, access and autonomy of AI agents is not captured well. Attack surfaces across models, memory dependencies, the infrastructure, training data, supply chain
Yeah.
risks, and integrations, which is something that is not very traditional, covering what part of the AI lifecycle has been targeted, so training, fine-tuning, deployment, interaction, human and social impacts, as well as your traditional CIA, and then the 3Ds, the disrupt, disclose, deceive, as well as some sort of aspect covering or acknowledging the probabilistic nature of model outputs and how outputs can be non-deterministic. So, how many times that you perform this exploit out of 100 does it succeed? Do you need, multiple shot attempts, or is it single shot? And the efficacy of mitigations, whether a mitigation would provide you 100%, which it never does in AI, but scoring for how secure your solution can be. So those are just a few that we'd love to contribute to the project.
Yeah, absolutely.
Yeah, that's hectic. Brain power, am I right? Okay, so second piece of security guidance. Google have described the 5 layers of defense they're putting on Gemini. So they heard about Echo Leak, they got a little worried. Now they're doing Markdown sanitization and URL redaction. So we're like, couldn't be us. So they won't render any external URLs, and they mark them as suspicious if they look a little unusual. And they're using, they have a lot of reputation-based calculations that they do as part of reCAPTCHA already. So they know when URLs are suspicious, and they're going to apply that to Gemini as well. So they're doing prompt injection content classifiers, which is the usual, everyone's doing it, except for they have a really large adversarial data set because they've run so many bug bounties and vulnerability exploit challenges that they have a lot to work with that they have taken straight out of people's attempts at those challenges to train their classifiers. So a lot like what Lakera have been able to do with their Gandalf logs, and Dreadnought have been able to do with their Crucible logs and things like that. So the next layer on top of that is security thought reinforcement, where they're wrapping user-provided input with additional security-focused instructions that remind Gemini to stick to the instructions of the original prompt and not be leaning towards anything malicious. So I wasn't sure whether they were pre-constructed, as in it wraps it and goes, you must pick out like the core instruction here is the thing, or whether they like compress the user's prompt into a set of safe instructions and then append that saying this is their core ask, but here is their full thing, don't miss any detail or whatever.
Yeah, interesting, because the idea of wrapping the user provided input with instructions to remind Gemini to do the right thing is actually kind of funny. It's like, remember, you must be secure.
Yeah, remember, be a good girl, boy, Gemini. Yeah. So it's actually interesting because we'll get to a piece of research later that I'm really excited about. And what I would do instead of them is I wouldn't wrap the input. I would actually just produce a new input that tries to capture what their instructions are at its finest, like most safe level, and provide it. So I'll tell you about a piece of research soon. What else are they doing? They're doing a user confirmation framework, which they already did a little bit, but now they're applying it to any interesting decision that Gemini makes. It does a user pop-up and says, are you sure you want to perform this action, and requires a human in the loop, which is fine, that's good, but I guess annoying for any autonomous use of Gemini that you want. And the final one is that they're doing end user security mitigation notifications. So what that means is they're using those logs that they had from the vulnerability research, the bug bounties, to detect indicators of compromise and show a banner to the user when they think there's something of concern. So for example, if the user prompt is like, oh, read this really sensitive file and tell me the key points, it might perform the action and put a banner up saying like, hey, this is something that usually happens when you've been prompt injected. You might want to take a second look at this prompt or something, which is good. So yeah, like I've got no doubt that the prompt guard is getting increasingly effective as they run more and more bounties, but it would be just very interesting to see how it applies to jailbreaks that are being released newly and people might not have employed yet in their attacks. So, but that's a problem that everyone is having with prompt guards.
Yeah, it's so interesting that they're able to use the data from their bug bounties and vulnerability research program. That makes a lot of sense. And part of me can't help wonder though if, like, would a real adversary use the kinds of techniques that academics or practitioners are using in those kinds of challenges? Like, would there be an inherent difference, or would they at least be similar in some ways?
Well, I think we were seeing it was pretty similar, right? Because one of the findings that we had really early on at Malever and the Threat Intel were that we would see an academic paper and a few months later someone would have weaponized it. So, the paper would have the disclosure of like, oh, this technique was only successful under these lab conditions. So you're like, hey, maybe it's not that bad, maybe it's not that applicable. Give it like 2 months time, and in that time people have been using it as inspiration until they've been able to crack it. So I think that academia might be a starting point for a lot of people's attacks.
Yeah, that makes sense.
Yeah, or informed attacks at least. A lot of people are also just sort of script kidding and shoving inputs. Yeah, awesome. So that's the security guidance. Now we have one tool this week. Thomas Rocha.
Oh my gosh, we should know this. He's our friend.
I know, I feel so bad. I interact with him all the time. He's awesome. He's a threat researcher, and he's released a tool that is very alike to Nmap in cyber, if you've heard of that. So a port scanner tool that is really often used for reconnaissance on a server, on like a network, to determine what ports are open, what services are being run within the network that you may be able to attack, depending on the security protocols they're running, whether they're open or need authentication, blah, blah, blah. It's a starting point for a lot of attacks. It's also very useful to check your own cyber hygiene. You can run Nmaps on your own network and see what you're running and use that to close things down. He has produced a tool that is being released at Black Hat, but he's done a demo so far, called Proximity, and it allows MCP server discovery and security scanning. So like a port scanner, it's a command line tool that lets you search for MCP servers, and they will deliver tool overviews that describe what tools are exposed, what prompts are being used as part of those MCP interactions, and other resources that the server is also exposing. And so this discovery is really good because not only can you see things manually, but he has integrated it and demonstrated how it can be integrated with a security scanner that he has produced called Nova, and it runs prompt pattern detections for prompt injection. And he runs that over the output of the discovery, the MCP server discovery, and is able to see servers that are potentially at risk of the tool poisoning attacks and things like that. So because the descriptions are open, he might see this one has picked up that it's got instructions, embedded malicious instructions in the tool description, and then more instructions to obfuscate it and point out, as part of runtime, before you have connected with the MCP server, that in the initial scan, we are ruling that one out. It's vulnerable. Moving on.
That's really cool. You also added that we recommend you follow Thomas. He has like a YouTube channel. I'm pretty sure he demos this tool on his channel. Is that right?
Yeah. So he's got a YouTube channel and he's done the demo there. Walks you through it, which is awesome. And yeah, I think the integration with a vulnerability scanner is really awesome, because not only do you have the discovery, but you have the confirmation of whether you can safely connect and interact with that MCP server or not. And I think that the next logical evolution for this would be to integrate it with something like ANS and your AI bill of materials. And so you perform this scan, and you know that your MCP server has been approved. You add it to your approved list, and as part of your continuous monitoring, you regularly reperform the scan. And you might be able to pick up when it's been updated. It will no longer be valid as the ANS agent that you've registered, and it should also be picked up by the vulnerability scanner as well. So we're now building a set of tools and protocols that can be used to make sure that we are able to do continuous monitoring and recognize when servers are malicious from the get-go or when they become malicious, which is a really, really good update.
Yeah, that's really, really good. And it's great that he's going to be releasing it at Black Hat too, because it means that a lot of the security community will be able to use it, test it, give feedback on it. I think the challenge is when you have one tool and the adoption isn't there with enough practitioners to be able to integrate it into the right kinds of workflows. So I know that this will be really, people will be really excited by this.
100% agree. All right, so that's all. Now we have news and research. News,
Mhm.
least interesting, so we'll gun through that. The first
Yeah.
one is that the New York Times have been lawsuiting, I don't know what the actual term is, OpenAI for a long time about use of their content in their training data. And I'm sure you're aware of this, it's been going on for ages. But they recently required, as part of the case, that OpenAI keeps all of its like user interactions for far beyond, the 30 days that you should be deleting data within, which is crazy. So they released an opposing statement saying that the data retention demands go against its policies. That's crazy. And they're trying to get it removed from the demands of the case because retention to that amount is going against every user privacy policy that is internal, and not so much in the US, but in the UK. The EU, sorry, that would be a big problem. The only people that aren't affected are the people that already have a zero retention agreement with them, which I assume would be governments and other organizations.
Yeah, interesting. Okay. Well, I know that this is ongoing and is sort of relevant to many other AI companies as well. So it'll be interesting to track this over time.
Yeah, absolutely. So the next one, I put this in the ACSC security partners chat actually, and I got quite a few lols. The director of national intelligence in the US, Tulsi Gabbard, she said that they used AI internally to speed up the review process for what files as part of the JFK assassination could be released that don't have any sensitive information in them. And that's okay. It was probably an internally used in an internal cloud or something. It wasn't at risk of any sort of public security risk. However, it's just a total misuse. They ended up releasing a bunch of documents that had people's social security numbers in there. So they've had to do a lot of cleaning up where they're reissuing social security numbers, addresses, different certs, sorts of PII for people. And yeah, it's just funny where AI is good a lot of the time and it speeds up manual processes, but it just shows that there was no level of interaction or even human interaction or basic level of regex checking where people were okay, we should start looking in these documents for variable name, security, social security number or address and other pieces of PII. So yeah, they just a misuse where they didn't apply enough other safeguards with it at the same time. AI shouldn't be your only filter when you can also apply really traditional methods as well.
Damn, when will people learn? And I feel like we sort of take for granted that this is kind of basic, but I guess to a lot of people who don't really come from a security background or mindset, yeah, I guess not.
Yeah, I don't know, national intelligence. But I think she was
In the name.
recently appointed. Yeah. Anyhow, what else is in the news? Tanya shared with us internally some information that is public now about Amazon committing 20 billion to expand Australian data centres for AI infrastructure, which is awesome. So that is separate to the TS Cloud that is being built for Oz government for data sovereignty purposes, and they're making a bunch of solar farms in Victoria and Queensland to contribute to the renewable energy promise that AWS has around the powering of AI infrastructure. So I guess the concern here that I don't want people to overlook is at the end of the day, we have all these views of AI as a thing in the cloud. It's like software, it's intangible, right? And those are where all the layers of security should be directed. But at its core, it needs compute. Physical compute. And that's the thing that people don't get about the cloud is it's not some magical thing. It is just that someone owns servers elsewhere that you're using. So these data centers are such a huge attack surface. And that's what we've been seeing in the warfare recently, right? Is people going for missile attacks on data centers because they know that will hold intelligence and other government AI services or just general infrastructure. It doesn't even have to be AI. And it is housing a lot of critical infrastructure. So I think physical security in AI is part of the supply chain attack surface that we need to be thinking of.
Absolutely. That's really interesting. And I think it's a conversation that people are starting to have, but we still are only just starting to see redundancy and resilient planning for it.
Yeah. So, in Australia, the government's all about data sovereignty, which is great. And it's led to us having as much internally, domestically hosted infrastructure as possible. But what happens if the very limited amount of data centers that we have here go down? Then you're not geographically distributed. And that's one of the benefits of like decentralization, right? Is that you have a lot of nodes that you can fall back on when something goes wrong. But at the same time, it means that all of those nodes are receiving your information, which is not good in some circumstances. So it's hard to determine which is the best method. Yeah, totally. So the final piece of news is the AI generated disinformation that was used in the Israel-Iran conflict very recently. So I don't know if you saw, but there was a downed F-35 image that Iran posted about Israel using F-35s against Iran. However, the photo was clearly AI generated because the downed ship had the downed plane had humans next to it. Yeah, that were like the size of ants. And like an F-35 is big, but it's not that big. And they had apparently houses in the photo as well. And so people were making jokes like, is this an F-35 or an F-350? Like, this thing's huge.
Oh my God, that's such a military joke.
Anyway, it was for the disinformation and it worked for the dummies.
Interesting. You would think that any AI generated image of that could have been better, right?
Totally. And the best bit is that it was amplified a bit on Twitter, etc., because a lot of social media now have these AI tools that you can call upon in the comments to be like, is this real or fake? And an AI bot comes in and pulls information from the internet and goes, no, what this person is saying is actually false. Here are the correct reports. And in a lot of situations, it's beneficial. But in this one, Grok on Twitter and a few others were mistaking the photos as genuine. So people went with it.
Interesting. Okay.
Yeah. So multiple layers of AI just messing up there.
Yep. Classic.
Yeah. All right. So finally, our research. The first piece is from friends at Dreadnode. They have now released a benchmark for the ability of assessing the ability of AI to perform hacks against other AI effectively. So for people that aren't familiar with benchmarks, they are ways for us over time to assess the progression of AI's capabilities for, in certain domains and certain tasks. So if we don't do this and we don't have these benchmarks or they don't accurately capture the capabilities, then we won't know when we've progressed far enough that they can actually be used safely in certain activities, for good activities like in healthcare and other critical industries. And also, we won't be appropriately prepared for the negative impact because we might think we're still a few years away from this AI being able to do X bad thing, when a benchmark can tell you pretty quickly whether it can do it or not. So in this case, they were trying to assess, are we at the point of AI hacking AI? Which is very similar to what other people have been doing on can AI contribute to regular pen tests at the moment and other sorts of hacking. And what they found was that through these CTF challenges that they got them to interact with across a few different kinds of attacks, like prompt injection, what else was there? There was model inversion and some other, I'm not sure if I've listed all of them. I don't think I have. It's in the report. They found that certain models actually did perform really well, but across the board, the performance varied on, I guess, the model family that they were trying it on. So, for example, Claude Sonnet had a 61 success rate, and the next best were Gemini and GPT 4.5. So all of the models that they ran tests on were quite good with prompt injection, but they struggled with model inversion and system exploitation. And some other findings that they had were that certain families of AI agents had really highly exploratory behavior. So they were exploring a lot and making a lot of false failed submissions and trying a lot of different attack vectors, whereas others went down deterministically like the same path every time and weren't getting that creative with their attacks. And what they also found was that when agents were able to use tools and use tools well, so that the agent was able to form outputs that were of the correct syntax for the tool, they had a much higher success rate in accurately performing the exploits than agents that had really high error rates in their tool use. Yeah.
Interesting. I am excited to see this. And when this came out, a few people messaged it to me. It really reached a lot of readers. I think it's really cool that they have 70 CTF challenges. Like, that's quite a lot. I'm sure our listeners probably, and even a lot of experts probably wouldn't be able to think of like 70 different kinds of attacks.
Yeah, well, benchmarks,
Or, like,
they
you'd really
have
have
to
to
be
think about it.
comprehensive.
Yeah, because it says that it's based on MITRE ATLAS and OWASP standards. I think there's like maybe 50, between 50 and 70 MITRE ATLAS TTPs listed. So it's really cool. It looks pretty comprehensive. I look forward to checking it out.
Yeah, no, it's really good. Like, a lot of times you see benchmarks that don't accurately, or they're constructed in a way that the test couldn't possibly accurately capture what they're trying to test for. So that's really annoying, but the Dreadnought guys, they make complaints about this themselves. So theirs has been well formed. And I guess the main takeaway actually that I totally missed was that the agents completed tasks with between 1,000 and 5,000 times faster than humans.
Wow, that's actually a massive increase. Like, my brain can't even comprehend being 5,000 times faster,
Yeah, exactly. And previously they put a paper out before this that was I guess a meta-analysis of the attacks that people were performing as part of their Crucible challenge. And in that, they also found that people who were leveraging AI to either completely autonomously perform the attacks or to give them a hand in manually performing the attacks, they were outperforming regular users hugely. So yeah, a lot to learn
Everyone
there.
check it out. Okay, we have 3 more pieces of research in 3 minutes. So do we want to give a quick headline and encourage people to sign up for the newsletter and see the full research?
Yeah, sure thing. So Security Lingua, this is what I was talking about with Gemini doing the wrapping of prompts. What these people are doing is they are tokenizing user prompts and reducing redundancy in the tokens to then produce a compressed user prompt that hopefully captures the true intent without losing any nuance. And it not only allows the user experience to remain unchanged, hopefully, but it allows prompt guards to much more easily determine the intent of an input. Because, for example, when you receive these super verbose, bloated, role-play, obfuscated prompt injections, this attack should be able to compress it in a way that the prompt that is actually passed through is able to be filtered a lot easier. So that's a super interesting idea, as long as I guess the tokens are being correctly reduced and not to an extent that you could still hide the jailbreak within it, though I think it's a really good idea. And there are some other questions I had about whether it would work with non-semantic jailbreak attempts, like using weird characters, etc. How would you condense that? And I don't know, there's a lot to think about there. The next piece of research, Deb, sorry, did you want to comment, or are we?
No, it's okay, keep going.
Awesome, speed running. Oh, wait, this one's huge. So this one is a protocol that works with ANS, and it's written by like Ken Huang and other people who are part of the OWASP AI VSS project. And they have released this protocol proposal called Agent Capability Negotiation and Binding Protocol, and it's for secure multi-agent collaboration. So the protocol is called ACN-BP. And what they're trying to focus on is that in these homogeneous agent environments where capabilities and permissions need to be changing very dynamically, there is no protocol in place. So they've provided a 10-step process about using ANS to perform agent discovery, doing pre-screening on their agent capabilities based on the ANS descriptions, performing negotiations, drafting agreements between agents, doing cryptographically binding like signature exchanges and secure sessions that have limited session times, so that you need to do renegotiations regularly, so that if agent capabilities change, it's not inherently trusted. And they put forward a whole open source reference like implementation guide on GitHub that they've also linked in the paper, and they've used Maestro to do a threat mapping of it as well.
Oh, I love that. I definitely want to check this out. That sounds really, really cool.
Yeah, it's insane, and probably a good thing that you haven't given me too much time to explain it, because I think I'd butcher it.
We could go on. No, I feel like it could fill 20 minutes if we wanted it to.
Yeah, absolutely. And finally is a piece on whether advanced reasoning models are actually better than just LLMs, or whether they are weaker in some fields. And so this is a problem that we've already spoken about, how sometimes reasoning models can either increase the attack surface because they reason so much that they tell you their reasoning path, and you could purposely exploit their reasoning path because it's been told to you, or maybe they are able to better think about things as being malicious and prevent themselves from going down that direction. Or alternatively, with the emergent misalignment problems that we saw earlier, reasoning models were able to reason themselves into doing malicious behavior because they were able to justify it so well with their reasoning processes. Anyway, they checked out DeepSeek, Qwen, and Llama reasoning models, and they basically found that they were hardened against some attacks like cross-site scripting attempts and malware creation, but they were more vulnerable to certain attacks like tree of attack, complex multi-step, I guess like logic abuse prompt injections. So they were using that attack, that logic chain, and exploiting that for prompt injection. They were really highly vulnerable to that. And suffix injection, which is where you append adversarial suffixes to prompts to override the rules. And they were super vulnerable to that. So the TLDR is safer in some cases, but not in others.
Interesting. I know that reasoning models is a big topic of conversation, research at the moment. One of our last podcast episodes was about evals in reasoning models. So it looks very interesting as well. And with that, that is all of the digest. That was amazing, wow. Miranda. Thank you.
Yeah. So you know what? I actually think that it's better if we have so many different things in the digest, because it means I really do speed run through them and talk at rapid speed. And hopefully that's better for listeners than hearing us go, So probably, we'll keep it intense. Yeah. But if people can let us know whether you'd rather get through less content in the same amount of time, where Harriet and I, actively engage in conversation and have thoughtful discussion about things, or whether you want like a quick and short TLDR where we tell you literally everything and I just like ramble at high speeds.
Yeah, because we could always do a couple of deep dives as well into certain things, time permitting, but it's all based on your feedback, so please let us know. But I found this really useful. This is like how I stay up to date with anything going on in AI security, and you explain it really well, Miranda, so thank you so much for that. But if you want to go read the reports, you should sign up to the newsletter, and then you can see the information, get all the links. We haven't always called out Miranda's like takeaways after each report as well. So please do that, give us feedback, and we'll see you next time.
Yeah, thanks everybody. Thanks, Harriet.
Bye.